Welcome to a lesson with Dr. Pal. Let's look at what happens when we plug something that's to the left of our initial point into our area function. Suppose we have area under the curve y equals t squared, and we start measuring our area at 0 out this way. But what if we were to plug in something negative or something over here? Now, in for x. Now let's impose a condition. Let's impose a condition that the area function, the derivative of it, is always this curve right here with x plugged in at a particular x value. So in other words, the derivative of the area function at this x value right here is still x squared. Well, that's positive, which means the area is going up. Because when you square a negative, you get something positive. So that means the area is increasing. But in the picture, it looks like as I move closer this way, it looks like I have less and less in the area. The only way to rectify that is to impose that this area over here to the left must be negative. So this area is negative of what you see. So in order to compute this, using this idea, this idea actually comes from the fact that the area function still over here, the derivative of it is still the value of the function. We actually end up being able to use the exact same idea that we had before. Let's try it out. So in this particular case, this would be equal to, we could do t cubed over 3. Going between 0 and -1, just see what happens. When we plug in a -1, we have a -1/3, and then plug in a 0, we end up just getting 0. So we end up getting -1/3 as supposed. And all we did was we just took the antiderivative and plugged in the two different values, starting at this guy and subtracting off that one. And notice how we got a negative area. And that should make sense in the fact that if the area is negative over here, then we're still increasing as you get closer to 0. Because if you're negative and getting closer to 0, then that's the same thing as increasing. Thanks for watching.